This video is about solving equations when in radians. We're very used to solving equations like this when we're working in degrees. We did that lots when we were in year 12, but now we're not doing anything in degrees anymore. We are working solely in radians. So it doesn't actually change your method too much here. The only difference is we need to make sure our calculator is in radians, and we need to make sure we draw our graph in radians. Otherwise, everything else is pretty much exactly the same. So I'm going to go through a couple of these examples really quickly. All I would do in this case is do sine inverse to both sides. So sine inverse of 0.5. As long as your calculator is in radians, you'll get the correct answer here as pi over 6. That's one solution to this equation. Remember that any time you do sine inverse or cos inverse or tan inverse, any time you use these functions, there is always an infinite number of solutions. Your calculator just gives you one of them. So we must draw the graph to find the others. So I'm drawing my sine graph here in radians. So I'm drawing my sine graph between 0 and 2 pi radians. We know it goes between -1 and 1. So my sine graph is going to look roughly like that. My first solution, pi over 6, is roughly about here. That's where my half was, my 0.5. So this is my pi over 6 here. I know there'll be another solution to when its sine equals a half there. So I need to find that angle. Using the symmetry here, just like we did in year 12, I know this green part here is pi over 6. So by symmetry, this green part here must be pi over 6. So this angle is pi over 6 less than pi. I'm just going to do pi, take away the pi over 6, which will be 5 pi over 6. So those are my two answers to this equation in radians. Let's do a slightly more complicated example. Now I've already set out all the work, pretty much all the working out here, just to save time, because like I say, most of this should be familiar. So the question was to solve this equation. 17 cos theta plus 3 sine squared theta equals 13 in the region between 0 and 2 pi. So the first thing I've done here is I've changed this sine squared to be 1 minus cos squared. Remember, sine squared plus cos squared is 1. So therefore I know that sine squared is the same thing as 1 minus cos squared. So I'm able to replace that there. I've then expanded the brackets, so the 3 times the 1 is 3. The 3 times the cos squared gives the 3 cos squared. I have then moved all of these terms over to the right hand side, so I get a nice quadratic to solve. I can either solve this quadratic by factorising, by saying 0 equals 3 cos theta and cos theta. That would be a -5, that would be a -2. So that's where I can get these solutions of 2/3 or 5 from. Or you could have just used the equation solver on your calculator here to solve that and get the 2/3 or 5. I know that cos theta equals 5, that will not have any real solutions at all, because I know cos only goes between -1 and 1, so it's never going to equal 5. However, cos theta equals 2/3, that will have a solution. So I would do theta equals cos inverse of 2/3, excuse me, which when I do that, I get 0.841 radians. Again, making sure your calculator is in radians mode. Then I have drawn the cos graph, and I'm going to use the symmetry of this graph. I know that this angle here is 0.841, so this angle here would be 0.841 as well by symmetry. So the angle that I want here is going to be 2 pi take away 0.841, which when you do that, you would get 5.44 radians. So those would be your two answers to three significant figures to that equation. So it's exactly the same method as how we solve trigonometric equations as when we were in year 12. Just remember, calculate in radians mode and draw your graph in terms of radians.